Have you ever looked up at a jumbo jet slicing through the clouds and just wondered, how in the world does that actually work? Well, it's not magic, it's engineering. And today, we're going to break down the entire 4-year degree that teaches you how to design these incredible machines. Think of this as your flight plan for becoming an aerospace engineer.
Okay, at first glance, I know this looks like a lot, right? But this mind map is the entire roadmap. Every single course, from your very first day all the way to your final project, it's all laid out right here. So let's zoom in and actually navigate this journey together, starting right at the beginning, in year 1. So here's our game plan. We'll start with the big picture flight plan, then talk about building that crucial foundation. After that, we'll launch into the core aerospace stuff. Then we'll see how it all comes together with a final project, before looking at how you can chart your own unique path with specializations. So let's start with that big picture. It's really helpful to think of this whole degree not just as a list of classes, but as a 4-year mission. It's designed to take you from the absolute basics of science to the super specialized knowledge you're going to need to design the next generation of aircraft and spacecraft. You know, every great pilot has to start with ground school. Well, for an engineer, your ground school is the first 3 semesters. This is where you build that rock-solid, non-negotiable foundation in science and math that honestly, everything else is going to be built on top of.
So the whole journey really begins with mastering the universal laws of the physical world. I mean, before you can even think about an aircraft, you have to get a handle on the fundamental rules that govern, well, everything.
And that means diving deep into physics, chemistry, and, yes, a lot of math. You'll also take courses like statics. Now you might be thinking, statics? Why would I study things that don't move for a job designing planes? But trust me, this is where you learn how forces act on a bridge or a building, and those are the exact same principles that keep a wing from snapping off in midair. It's absolutely crucial. Okay, so you've got the scientific rules down. Semester 2 is all about building your engineering toolkit. This is where you stop just learning science and you start using it like a real engineer. And this is where things literally get moving. You'll take dynamics, which is the study of objects in motion. This is the physics that governs everything from a simple baseball all the way up to a rocket launch. You'll also learn to code, which is like a superpower. It gives you the ability to model these complex forces and start solving actual engineering problems. Semester 3 is really the final bridge you cross from being a general engineering student into the specialized world of aerospace. Now you're diving into the core mechanical principles that govern every single system on an aircraft or a spacecraft. And this is the moment where it all starts to click. You get your first official introduction to aerospace engineering class. You pair that with courses on how fluids, like air, flow, and how solid structures handle incredible loads. This is it. You've officially left general engineering behind, and you have entered the world of aerospace. All right, ground school is officially complete. That foundation is set. Now it's time to take your first flight. These next 3 semesters are where you focus exclusively on the core challenges and ideas of aerospace engineering. This is the fun stuff.
In semester 4, you really start to speak the language of aerospace. You're learning the fundamental principles that, honestly, separate this field from all the others. So, that big question, how does a 200-ton metal tube actually stay in the air? The answer begins right here, with the star of this semester, Aerodynamics 1. This is a huge milestone. And you'll pair it with Structures 1 to make sure your vehicle doesn't fall apart, and Automatic Control to start building the brains behind the whole operation. And this really gets to the heart of it all. See, aerodynamics isn't just some abstract theory. It's the science that answers the most fundamental question we have. How does a wing actually generate lift? This is the physics that literally gets planes off the ground.
Okay, so you get the basic physics of lift. Awesome. But how do you actually build a vehicle that can harness it? And, just as important, how do you get enough push to move it through the sky?
You can totally see the logical progression here, can't you? You're building directly on what you've learned. Aerodynamics I becomes Aerodynamics 2. Structures I becomes Structures 2, and now you add a critical third piece to the puzzle, Propulsion I. You know how a plane stays up, now you're going to learn what pushes it forward.
Exactly. You know, if aerodynamics is the how of staying in the air, propulsion is the push that gets you there in the first place. This is the science behind everything, from those massive jet engines on an Airbus A380 to the incredible rocket engines that literally break the grip of Earth's gravity. It is all about generating thrust.
By semester 6, you're looking way beyond just getting off the ground. The questions start to get bigger. How do you control the aircraft with incredible precision? What happens when parts start to vibrate at super high speeds? And what if you don't want to stop at the edge of the sky?
So this is where you tackle aircraft stability and control, which is all about making the vehicle do exactly what you tell it to do. You'll dive into avionics, which is basically the complex electronic brain and nervous system of the aircraft, and you even get into space mechanics, applying everything you now know to the world of orbits and spacecraft.
And here we are. Welcome to the final year. The lectures start to wind down and the real-world challenges ramp way up. This is where all that theory you've been learning for 3 years finally gets put to the test. It becomes less about learning and more about doing. This is where you really make the transition from student to engineer.
This entire year is about one thing: putting theory into practice. You'll get real-world experience and an internship. You'll learn the hands-on details of aircraft maintenance, and then you'll pour every single ounce of knowledge from the last 3 years into one single massive design project. This is your final mission.
And finally, after you've mastered the entire core curriculum, it's time to chart your own course. The electives are where you get to decide what kind of engineer you really want to be, focusing on the problems and the technologies that truly get you excited.
Do you want to design the most efficient wings ever created? Then you can dive deep into advanced aerodynamics. Are you fascinated by engines? You can specialize in propulsion. Or maybe you want to pioneer the future with drone technology, or apply cutting-edge machine learning to flight controls. This is where you don't just finish your degree, this is where you launch your career.
So, there you have it. From the fundamental laws of physics all the way to the complex art of automatic control, this 4-year mission gives you all the tools you need to build the future of flight. It's a demanding journey, for sure, but it is an incredible one. So the real question is, what problem will you solve?